My name is Roldan, and I'm going to do just a brief intro of Glovo and the speakers. Then Sad is going to cover the iOS part about UI testing, and then Bachiri will talk about the Android part. Then we are going to have a Q&A session where you can ask whatever question you want, and later we'll go to networking. You are going to have pizzas and something to drink. Probably if you are here is because you follow us in the meetup group. In case of you don't, you can check here this website. We try to do meetups every month. And this is not exactly meetup, but similar. By the end of March, we are doing the Women in Tech conference. You have the link there to register. Zero, our CTO, is going to talk there, and also another CEO from a different company. I think it's Lean In or something like this. You are all welcome to come here. It's going to be actually in the other amphi, which is bigger. Usually for the one in tech, many people attend. I hope all of you here know Glovo. Have you ever ordered from Glovo? And keep your hand raised if you order anything that was not from a restaurant. Less hands there. The mission in Glovo is to be the go-to app that delivers instant solutions for all food, grocery, and shopping needs. Still, many people think Glovo only do burgers, pizzas, and so on. You can order whatever you think. We see Glovo as a big marketplace in your city that can deliver anything. Books, your groceries, Rose in San Jordi, whatever you want. Glovo is not operating only in Spain or Barcelona. We operate across 25 countries, most of them in Europe, but some of them as distant as Kazakhstan, Nigeria, Kenya. There are thousands of cities, partners, couriers, but everything, all the operations are here in Barcelona. This is the headquarters. We operate everything from here. Going to the tech department, also many people think Glovo is small. We are around 500 engineers, tech, data, etc., across many different teams, many different clusters. There are many interactions between all of these clusters. Probably this is a common setup, and this is going more into the talk. You usually divide all your product teams or your teams in different product teams that are specialized in different domains. Checkout, login, ordering flow. Usually the stakeholders of these teams are the customers or the partners or the couriers, and they are working usually in public-facing features. And then you have also another layer, which is platform. Platform usually doesn't work for anything that is visible for the users most frequently. And their stakeholders are actually the product engineers. I'm sharing this because today the talk is about the mobile platform team, which is part of platform. You will find things like foundational teams, SRE, storage, infra, edge, anything related to CI/CD, the infrastructure of your company. It should be a platform. And the mobile platform team, the two speakers are going to talk about some improvements that the mobile platform team did during the last year. In this team, the mission of this team is to enable mobile technology to evolve and scale as company grows with good developer experience. Mobile in Glovo is around 60 to 70 mobile engineers, Android and iOS. All of our applications are native. We have one application for Android, one for iOS, which is the one that if you ever order from Glovo is the one that you use. So this team supports all of these 60 engineers to try to work faster and safely and scale as the company grows. And one of our main drivers of everything that is done in the mobile platform team is the developer experience. Fortunately, this is a topic that has been increasing and been getting more traction around all the industry. There are probably many definitions. My favorite reference authority in this is Nicole Forsgren. She's the brain behind Dora, Space, and many other things. She publishes constantly papers about productivity, and this one was the last year. She and her team identify what are the key drivers of developer productivity and happiness. And they analyzed like 20 different ones that they found that there were significant correlation with productivity. And they grouped them and analyzed them in 3 core dimensions, which are the 3 that you are seeing here. And flow state, everyone works better and more productive and more happy if they are concentrated and they're focusing on what they are doing. And for that, you need especially 2 things. One is reducing the cognitive load. We believe that we are quite smart, but we are not. Our brains are quite limited for what we think we are. We cannot do many things in parallel. We cannot track of many items in our heads in queue. So reducing the cognitive load is a key thing for developer experience. You will see later in the presentation from Bachiri and Sad that some of the improvement that we've been doing for UI tests is making the tests easier to build and easier to maintain. Also, maintaining UI tests probably is harder than writing usually, because you write one and you run thousands of times. And the other, also quite connected today, is feedback loop. The faster you receive feedback from what you are doing, from a release, a test, or an execution, the better you are going to work. You are going to be more focused. You are going to be able to do what you are pretending to do. So also, we'll see that the team work a lot in reducing the feedback loop. And other ownership and scope in this mobile platform team is mobile architecture. This team is also giving guidance about how to build applications, including modularization, also observability, what should be observed, how your dashboard should be, app performance. We want our app to be smooth. I hope if you use the app, you find it smooth and nice to use. We have several key drivers of performance that we constantly monitor. This team, besides creating dashboards and guidance, they also work a lot in improving performance. Also some foundational parts, again, so product engineers can focus in what they know, which is the domain, owning the Play Store, the App Store, and everything related to CI/CD and releasing. And of course, CI is some of the main topics that we're going to be talking today, because we are talking about UI testing. And our speaker is going to be Sad Bachiri. Sad is going to start. Thank you very much. I hope you enjoy. And probably he's going to stop in a few minutes to drink some water, because he's not been drinking in the whole day. Just wait for a few seconds until he recovers.
Sure. Thanks, Roland. Okay, let's start. So my name is Saad. I'm an iOS engineer here at Glovo, and I'm part of mobile platform team. So today I'm going to be presenting the iOS side of the UI testing. So let's start with the question, why UI test? So let's start with the business reasoning. So what do you think is the percentage of order being happening from the mobile platform? The percentage of order we receive comes from mobile apps like iOS and Android. Any rough idea numbers percentage-wise? 95%, very close. Okay, so it's 96% of the orders comes from mobile apps. So you can see like how mobile app stability is quite important for us. Okay, an outage in production for mobile apps can affect partners, customers, couriers, and Glovo in terms of revenue, in terms of stability, and in terms of trust. So it's not only that customer app is affected. Okay, thanks. Couriers are also affected. Partners are also affected because they are not able to provide orders. And similarly, Glovo as in whole is affected. Okay, so another reason to look at why UI tests are important. So in a bigger company, when you have multiple teams divided into multiple clusters, you work on your own features. So imagine that on the top, you have your own team, and that is your scope on the top of it. But eventually, when you ship the app, all features are combined into one big app, and then it is shipped. So you don't usually touch other team's code. You only care about your code. You probably write unit tests to make sure that your own codes work. But what is that thing which makes sure that the whole app work seamlessly across like how the user actually feels? So here comes a UI test which makes sure that your features, when integrated with the other features, work seamlessly. Okay, so let's talk about the state of affairs before we started working on this particular initiative. So for us, UI tests ran nightly before this, and they were taking almost 1.5 to 2 hours, and that's why they were running nightly. We couldn't build them as part of our CI checks because you cannot wait for a feedback loop of 1.5 to 2 hours. And I'm talking here on average for both mobile, iOS, and Android. Okay, and regarding flakiness and failures, 50% of the test failures were failures, or failures due to not actual failures, but flakiness. That is a big number. And of course, with 50% of failures, you have low reliability. Nobody trusts the system. And if somebody trusts it, this happens. Okay, so we also have limited visibility into test results and failures. By visibility here, what I mean is that we could look into the UI test workflow and see, okay, this much tests have passed, this much tests have failed, but we didn't have the holistic visibility of, let's say, in the past week, how many tests have failed, which tests are constantly failing, which tests are taking more time, which tests are flaky, which teams are producing more tests which are failing. So we didn't have that particular observability. Okay, so we now come to our motivation. So the first motivation is all core flows work as expected and detect regressions. What do we mean by core flows? So core flows are any flow which is critical for the user to make an order. So anything which you do from your home screen till you or place the order and after tracking, they come in core flow. So we wanted to make sure as a part of motivation that core flows should be covered and there should be no regression, at least from the UI test part. Then the next part is make feedback loop faster by running it as part of PR checks. As I've already mentioned, we were running it nightly. So what would happen is that let's say in a day you would merge 30 PRs. In the night, UI test runs, it fails. The next day, developers come. Okay, something has failed. Let me just do git bisect. You figure out, okay, this particular commit has failed. You tag the author. Author has to context switch. Probably they are working on something else, and then they have to come back and try to figure out what's the issue. So with this particular thing, we wanted to make feedback loop faster by making sure they are not able to merge changes into the develop if they are broken. Okay, the next thing is remove flakiness and improve testability. So let's say if we want to bring them in run them as part of our PR checks, if they are, let's say 50% of the time they are failing, how would you trust it? So how would you know if the failure is real or maybe it's flakiness? And that if it's flakiness, you would just like retry. Just let me just press the retry button, and maybe after 15 minutes or whatever time it takes, you will figure out, probably it failed again. It's not flaky, it's my failure or whatever. Okay, the last part I've already mentioned in terms of making feedback loop faster. We also have the drive to reduce context switching, because when we tag the author, they need to probably look, or maybe there are multiple teams involved in that particular test or that particular feature, and they need to like work as context switch and work on that particular test to make the fix, or maybe even fix the feature which actually broke the UI test. Okay, with those motivations, we have these objectives which are quite aligned with our motivation. We should run UI tests as part of our PRs. We should regain UI test accuracy, fastness, stability, and then run UI test P90 time. P90 of the workflow of the UI test should be under 12 minutes. How did we get this number? So our CI already without UI test contains checks for the unit test and alpha. They were running in a P90 of 12 minutes. So we were targeting that number so that our UI workflow does not increase the feedback loop of the whole PR. So that like when you create a PR, after 12 minutes, you should know. It should not be that probably after 30 minutes, just because of UI test, you would know that your PR is failing or something like that. And of course, the last one, improve test reliability to more than 98%. Okay, so now we will talk about a little bit on the iOS side. So the sequence would be from where we started. We have talked a little bit about that already, but then I will focus a little bit on the iOS side. Then we'll talk about finding alternatives. We will see what we were actually looking in alternatives. Then we'll talk about challenges, stability, and reliability. And at the last, we will finish with some debugging tips. Okay, so from where we started. So as I mentioned, we were doing nightly runs, and as I already mentioned in the previous slide that we were running around 1.5 to 2 hours. That was average for both Android and iOS. For iOS, previously we used to run in AWS device farm, but we were seeing some problems. We shifted out to simulators, and those workflow took around 50 minutes. And of course, since we were running nightly, they were giving slow feedback loop, and of course there was flakiness which affected the confidence, and it also increased the workflow time, because when you have flaky test, you actually sometimes have a rule to retry just to check like, is it flaky or is it a real failure, and that increased the overall runtime of the workflow. Okay, now let's look at an overview of what the UI testing looks in a bigger picture. So for the first part is that you have to write the test. So you have multiple options from the iOS side that you can write in XCUI test. You have APM, you have Earl Grey. For this particular part, we wanted to be as native as possible to the Apple technologies. So for this part, we will not be talking much in the differences, but we went with XCUI test, and the major drive for us was that it is native. Then we will talk about backend. By backend here, I mean that how you should get the network to respond to your particular request. You use a real network, you use a mock network. If you use a mock network, which things you should use to mock it. Okay, then we talk about where to run. And you can run on multiple things. You can run on simulators or real devices. And if you run on real devices, then you have to figure out who is going to be in infrastructure, what is going to be your infrastructure in either in Firebase, Amazon, or maybe some other external tooling. And then at the last, we talk about observability, that which we were missing earlier, that we should have a picture of at least previous weeks or maybe the previous 5 to 6 weeks of how the UI tests have been performing, which tests are degrading, which tests are going fine, which test duration is taking more time, and even tagging it with teams. Okay, so before going a little bit deep, I would like to just set the ground for how XCUI test works. So we have a host app. We have the host app, which is in our case is Glovo, and for which we want to run our UI tests. And then we have our UI test runner app. So this test runner app, you will write your test in the test runner app, and then this test runner app will make some interactions with the host app. So first, if the first interaction it will try is that it will launch the host app. The further interactions, let's say it's launched the host app and it lands on the login screen, it will try to make some interactions. Let's say it tries to tap on the login screen, and then after making the login screen, let's assume that it is a successful scenario, and it will assert that did it land on home screen or not. In this particular say, you will see that all the arrows are in one direction. You cannot have any communication in reverse. Like when I say in reverse, what I mean is that you don't have any access to internals of the host app code-wise. So you cannot say like if this function, this function. The only way you can interact is via that particular app instance. And what that does is it scans the UI of the host app. And when it scans the UI, it gets a UI hierarchy. And this hierarchy you'll get only like button details, like button size, maybe button text, and accessibility levels. That's all you get. So the only thing is you can do is make some interaction and then put some assertions based on which view has it navigated to. Okay, so based on that, you will see that is the test successful? Is the test successful or failing? And then this is a typical black box testing framework. Sorry. Thanks. I think I feel a little better now. Okay. So we have already finished the writing part. Let's talk about the backend, by which I mean the network part. So we were formerly using WireMock, which is a popular open source software. It's written in Java, highly stable and reliable. And it also provides a feature of automated recording of mocks, which is like it is famous for that you just put your WireMock in recording mode. And while you navigate through your application, it will record all the mocks, and then you stop the mock recording, and then later when you run your test, it will have all those mocks. Okay, so, but there were some problems we were facing with WireMock. The first problem is that it cannot run as part of UI test runner. So what I mean by that is that WireMock is a JVM application. You cannot run JVM application on an iOS device because it does not have JVM. So for that, you need to run WireMock on something like external, which could be EC2 instance or any compute instance. So we wanted to make sure that we are able to run the WireMock server as part of iOS device itself, because otherwise we have to spin up a separate infra, and this would give us a lot of problems later in parallelization. And the next point is related to that if we are not able to run the mocking server as part of the device itself, we will have some difficulty in parallelization in case of running them on Amazon Device Farm or Firebase Test Lab. Actually, for us, we actually got this motivation from Android because they were using WireMock, and they could run WireMock on the device itself because of the Java ecosystem. And for the first 2 points, I will talk a little bit more detail in the next slides. And the last point is devs had to go to terminal to start the server separately. So it was a bad developer experience. So let's say I fire up my Xcode, I want to run this particular UI test. I see the beautiful test diamond, I click on it, and the test runs and fails. And then, I need to run my WireMock server. So I jump back to terminal, I run my WireMock instance, I go back to my Xcode, I press the button again, and the test succeeds this time. So it was not very straightforward to just run the test and it will pass. Okay, so how UI test used to run? As I mentioned that we have on the left side, we have an iOS device. On the right side, we have an EC2 instance or compute infra. We would have UI test runner. We have UI test runner app, as I've already explained, and we would have our host app. UI test runner app will launch the Glovo app, which is the host app. And then at the same time, we should be ready in our EC2 instance, which should have already spun up the WireMock server. And when UI test runner app will press the login button, some action will happen on the host app, which will trigger the request to WireMock server because we have set the URL to the WireMock server, and then it will fetch a response and success or failure. Okay, so the only way to go fast is to scale up vertically or horizontally. Vertically, when you go vertically, what you actually like make your machines beefier. In case of iOS device, or it wouldn't make sense. We knew that our tests are working fine. The only problem is we need to make sure that we need to parallelize them. So we wanted to scale horizontally, and we did face a problem that if we want to go with WireMock, you will see that the number of shards we create, we will have to create the same amount of WireMock instances, because we cannot have one WireMock instances and all shards pointing that, because it would conflict with the mocks. So this was a problem. If we, let's say today we are running 3 shards and tomorrow we want to run 5 shards, we need to have that logic in place where we increase the number of WireMock instances, or that much EC2 instances to match. And this was a little bit harder to scale. It's possible, but harder to scale. And moreover, with we will have iOS device, let's say in Amazon Device Farm or somewhere else, or maybe Firebase Test Lab. Then let's say we launch our EC2 instance in AWS, and now the mock server has to travel through the internet to find its way to the WireMock server, come back, more chances of flakiness. Okay, so now let's talk about finding alternatives. The first one was alternative or candidate we found was Flying Fox. Then there was Swifter. Then there was Hummingbird. Then there is a strategy called mock network layer. And then there is Embassy. Out of these 5, Swifter, Flying Fox, Hummingbird, and Embassy, they're all tools, not tools, actually servers written in Swift. They are just servers written in Swift. And then we have the mock network layer, which is not a tool, but it's a strategy. So what you do here is that before you hit your API client, you mock it in a way that it does not even hit the URL session or LAMO file. In this case, you just return the mocks earlier. So you have internal logic which actually figures out which mocks needs to be returned at some point. Okay, so things actually we were looking for replacement. The first I've already talked about extensively that it should run as a part of UI test runner, and this is like very bare minimum for us. Of course, it should be stable. It should support CocoaPod because we use CocoaPod as a dependency manager. And ease of usage, that its API should be declarative in a way, and also it should support overriding of response for a URL. So let's say in a same test, I want to make sure that if I call the home endpoint, I should get a response. But later, if I call a home point, I want a different response just to make sure my test is working fine. So it should provide a support to override the response for the same URL. The first one we kicked out was mock network layer, because we didn't want to complicate our networking solution and tie it with the, just for the sake of UI testing, we didn't want to tie our UI network layer with the UI testing logic, or it would tie it at least a little bit. So that's why we kicked that out. And we were left with Swifter, Flying Fox, Embassy, and Hummingbird. They are pretty much similar, except one thing: stability. So what we did was that we ran a lot of tests on those tools, and then we figured out which one is the most stable one. And I will actually talk a little bit about how we did that POC. And at the end, Flying Fox was the winner. So we went with the Flying Fox. And how Flying Fox works. So eventually you have a test. You have like a test user login or whatever. Before running that test, you just make sure that in a setup function, or just before even that, you press some buttons, you actually spin up a server. So you initiate an object of HTTP server, you provide a port, and you start the server. And it will spin up a server on the local host. And then you append all the routes which are required for that UI test to run. So you will append for v3me, you will get this particular, get the mock from this particular JSON. And whenever you call that v3me, you will get that particular response back. Okay, the immediate effect we saw with this was that previously, as I remember, if you want to run test, you click on test daemon, it fails, you go back to CLI, you run the WireMock server, you come back. But with this, you just press the button. Since you already have a logic of running the server early, it will run the server, it will append the routes, it will run your test, and it will succeed. You don't need to go anywhere else. Okay, so now we have completed the backend part, which is the mock. We will went with mock networking. And now I will talk about the next 2 topics, which are quite correlated, like where to run real devices and simulators. And the next part is, if you go with real devices, then what are the options we have: Firebase, Amazon, and others. So these are the 3 main candidates for us. Actually, Android was a little bit ahead of this in terms of, so they did a lot of research, and at the end we were left with these 3 things. So Firebase Test Lab, It has its own Google Cloud. It's good CLI. It has a rerun support. It supports sharding, which actually we want for parallelization via Flank. And then, of course, the price, which we needed to consider. Then there is Amazon Device Farm. It didn't have sharding support by default. It's had a very good CLI. Code coverage support is not there, of course, price. And then simulator, which are my favorite. But yeah, it comes with its own edge cases. It's need dedicated infra. So let's say you want to run or parallelize your things on your simulators, you need to procure infra upfront. So you need to procure whatever procurement method you use, you need to procure them upfront. Or maybe if you use on demand, it may make sense for you. But again, it's difficult to scale that because of the same problem that you need to procure infra and then deploy your parallelism test. And then the last point is no out-of-the-box sharding support. If we want to do sharding, we will have to write all that logic ourselves. So with these things in mind, we eventually went with Firebase Test Lab, and the reasons were infrastructure stability, execution speed, accessibility of the format results, which was standard JUnit reports, which we actually needed because our observability solution grabs those reports, JUnit reports, and pushes into our observability solution. We have a centralized observability solution, which we use across our whole company, and we wanted to reuse that. So JUnit reports was a good thing for us. And it supports sharding, but not directly. We have to use a tool called Flank, which would enable us to deploy multiple shards on Firebase Test Lab. And then, of course, user management through Google IAM so that your developers can access the reports of the UI. They can also see the videos and this sort of stuff in case they're interested, or maybe there's a failure and they want to fix it. The few shaky points for Firebase Test Lab is the test rerun support. Of course, as I mentioned, that it supports rerun, but at a shard level. So let's say we have 60 tests. We have 60 tests, and we want to run them on 3 shards. So 20 tests on each shard. But let's say in the shard one, the test one fails. What will happen is that if you have a retry strategy, it will rerun the whole shard, not that individual test. So let's say if your shard takes 10 minutes, it will run all of those tests again, merge the result, and then it will see, okay, so one test passed in one of the reports, and the other time it failed. So this is flaky, others are passing. So it will make that kind of a decision. But what we wanted is test support on an individual level. So that was a little bit of challenge for us. And then second last point is also the same. It reruns whole shard instead of only failed tests. And the last point is that it takes extra time, 1 to 3 minutes spent on creating the shards. Whenever you deal with on-demand instances, either it's AWS, Google Cloud, or whatever, if you are looking for something on demand, it will need some time to provision, and then it's available to you. And this time would cost us extra because we were looking at minutes of accuracy. Okay, so these were the few problems, and let's share a few solutions for that. So it didn't support sharding by default, so we went with Flank because that would allow us out-of-the-box sharding. And then there, of course, the second one is rerun whole shard instead of only failed test. For this, what we did that we adjusted our configuration to never retry that UI test. So it fails, okay. We will get the result back. We will pass the report. We will say, okay, this particular test has failed. We will create a new shard with only that test or only those tests which have failed. In this case, you don't run 20 tests again. You will only rerun those tests. Those have failed. So we will then again do the same thing. We will get the results back, merge them, and figure out if some test is flaky or it's actually failing. And the last thing is like takes 1 to 3 minutes of time to start the shard. We don't have a solution, unfortunately, as of now, so we suffer. Okay. So the last point is observability. As I've mentioned, that we have a centralized solution, which we use GitHub Actions. We have a centralized GitHub action, which actually we just pass on the JUnit reports, and it publishes the result. Actually, Bashiri, in his Android part, will explain a little bit more about this. Okay, so what were the results after the changes? So we started with something like 50 minutes, and we ended up with almost 12-minute average with these things, and 15 minutes of P90 time. And it's pertinent to mention here, when we started, the number of tests were around 40 or 35, something like that. And then when we finished, the number of tests were growing 50. I will also, we can also later talk about the number of tests we have right now. We are above 100, and actually probably 120 or 125. And the UI test average time is 15 minutes. It has increased, but because the number of tests have increased. And the P90 time is around 19-20 minutes, but we are keeping the same number of shards 5 which we had earlier. So if we wanted to minimize a little bit, we could by increasing the number of shards, but we are investing into some other solutions right now. So feedback loop, of course, we went with shift left approach. We moved from nightly build to CI checks, and developers could immediately know that before merging the change that something has failed. And we moved the reliability, which was actually a big factor for us. We moved from 50% to 99% of the weekly stability. Okay, so let's talk about improving stability and reliability. What did we do there? So of course, one of the issues with tests is that they are flaky. So how did we fight flakiness? And what are the major causes of flakiness? So one of the major causes of flakiness is that when you have an XUI element, as I mentioned, you have a test runner app, you have a host app. Test runner app can check like, is this element exists? Okay, if it exists, let me tap on it. So you want to make sure that if an element exists before you tap it, otherwise if you tap something which does not exist, the test will fail. So the problem here is exist only checks the existence of some UI element on the screen. So let's say you have a login button and suddenly a pop-up appears. Your element exists in the view hierarchy, but it's not tappable. So let's say when the UI test runner will try to tap it, it will probably dismiss the alert dialog, and eventually it will assume that the login should have happened, and it will try to run the next step, but your test has become already flaky because sometimes maybe the dialog appears and sometimes it doesn't. So you need to make sure that there is another property called is hittable, which actually checks is that particular element directly hittable or not. So if that element is hittable, it will tap it, otherwise it will wait. So then it will wait, and then it can have a certain timeout based on something like you have 5 seconds to wait in maximum, and then it can fail or take next steps. Okay, the other point is relying on default system values. So when we are writing tests, usually we are probably only taking into few things into account, especially related to, let's say, our locale. And then we say, okay, everything is yes. And let's say you have a phone number field, which actually takes locale into account, and based on that locale, it tries to maybe, prefix a phone number or something. And since you have a locale of US in your system, and when let's say somebody else runs in their laptop or somewhere, they have a different locale, the test is bound to fail. So you should make sure that do not assume anything, be very explicit while setting, and don't rely on default values. Okay, so those were things for flakiness. Now let's talk about what are the causes of long runs. Okay, so waiting for element which should disappear. So as I've already mentioned, you wait for element if something has not appeared. But sometimes you have a use case where you want to check if the element did disappear or not. In this case, XUI elements does not provide any kind of API to check the disappearance. So if you want to, let's say, check something has disappeared, you will probably wait for probably 5 seconds. You will say, okay, let's keep checking. And then after that, you will assert that is it false or true? Did it exist or not? So actually, you are wasting 5 seconds. So you should always assert on something which should appear. So let's say you tap on login button, you should never test that login button disappears or not. You should check what should be the next step, because every interaction should always have an action, and you should check for that. So unnecessary use of wait. So this is the particular API which I was mentioning that you need to call to wait that some XUI element exists, and then you try to run. So if you use it excessively, this becomes a blocker. Like, let's say if I check for everything, if login button exists, tap. If this exists, tap. And let's say I have 50 exists in my test, what will happen is that this particular function actually waits at least a second before making the decision, even if the element is already there for some reason. So probably you need to, what we actually did is that we actually checked if the element is hittable. No, it's not hittable. Let's wait now, because we check it is hittable first instead of directly just waiting. So it was a small improvement, but it makes a difference, because if you have, let's say, 50 waits in an app, and let's say you wait around 0.75 seconds to 1 second, you will be actually wasting 20 to 30 seconds just waiting. And stop unnecessary tasks. What do I mean by unnecessary tasks? You should stop static images instead of fetching images. So instead, in your whole application, stop your images with your local images, like say maybe a local icon, so that no network call is made. And avoid doing any network operation except the mock response. So any network operation related to observability, related to analytics, related to any third-party libraries which you think are not necessary for the UI test, disable them. Okay, so what else did we try? So we tried actually a lot of things, but there are a few important ones. So we started with parallelization. Let's say we wanted to run n shards on one VM. So this was a more of a simulator-oriented approach. So let's say in the CI, if we could hypothetically, because when we run tests, there's one simulator running all the tests, 60, it will run all the 60 tests and then close. So we thought let's make sure that we run tests in parallel. We spin up 3 simulators or something like that and run 20 tests, 20 tests, 20 tests, and let's see what happens. So the only problem is that we need to make sure that each test is assigned a different different server, because we don't want, because they are all running on the local host in this case, right? So, and this is a VM. Remember, this is not an iOS device. This is a VM. So we didn't want to make sure that we wanted to make sure that test mock response do not conflict with each other. So, and the other difficulty, one of the difficulties is that you need to build once. You cannot do multiple bits. You build once, and then you figure out, then you make different shards out of those, and then run the test. Okay, so this is how it looked like. So you see we have already created 3 shards. The first one is already running, the second one and third one is spinning up, and the first one is already running, and then so on. So now we are able to parallelize. We were quite happy. Okay, now we are like, probably if let's say 60 tests run in probably 60 minutes, they should run in 20 minutes because we are parallelizing stuff. But eventually we also get reality checks in life. So this works fine on a local machine because we have our quite beefy machines. I personally use M2 or M3, I don't even remember, with 36 Gs of RAM memory and I don't know, maybe 8 to 9 cores. So this was working perfectly on my machine. But in CI, we have 4 cores, M1s with 8 Gs. And eventually when I run the first batch, it did the reverse Uno effect, and they actually slowed down. So the first 20 tests I ran actually were supposed to take around 10 minutes, but they took almost 15 minutes. So eventually they were actually got more slow. So I think this can work fine locally if you want to iterate faster, but it's not a solution for a CI unless you have a very beefy machines. Okay, so reset instead of relaunch. Sorry. Okay, so one of the things we noticed that most of the time your app takes is in the restart phase. So for us, it was taking 7 to 10 seconds for the restart. So you would wait 7 to 10 seconds for the app to start, and then the first interaction would happen. In this case, let's talk about the login example. It will tap on the login, and maybe the test runs for 5 seconds. It just taps the login and check, okay, the login is successful or something like that. But you are spending 7 to 10 seconds initially just to start the app, and this was quite a lot. So let's say if we have 100 tests, hypothetically, we will be spending at least 700 seconds just to make sure the app starts. So that is quite a lot. So if we are able to somehow bring that down, we will achieve our major goal. So, but what does reset here mean? So for us, reset here means that we just go to home screen, because 90% of our tests started from home screen. So we know that was a starting point. So if we somehow navigate to the home screen, we will be sure that we don't start the app. Okay, so, but if we are resetting, let's say, if we, let's say, somehow are able to navigate to home screen or default screen, whatever that is, how do we make sure that the state of the app gets reset? So maybe the test one wanted to had a mock with a user logged in with a different permissions, but the test 2 is totally different with a user logged in with a different permissions. And if you have some residue from previous run, you can have a lot of flaky errors. How did we make sure that this does not happen? We reinitialize the DI container. So we have a DI container, which at the top, we have a top level container. We just swap that. We just kill that container, recreate that particular container. Then we reset user defaults. Of course, if we have some residue left from that part, we just reset that. And we also reset the UI window. Okay, so this is how it looked in production. For the first time, it will take 7 to 10 seconds. Okay, this is now running. This takes, then it will probably tap groceries, and then it will go to store. It will try to order, maybe confirm order, goes to payments. Okay, the order is good. And now instead of resetting the app, it goes to home screen and the next test starts already. So you save almost 7 to 10 seconds here. And if you apply this at scale, you can get major benefits. But how did we do that? It was quite a hacky solution. But if you see here, we have a dot here. So what is this dot? This is a 1 by 1 pixel, which we introduce in our app this is a hidden button, but if you just tap it, it will reset the state. Since only way to interact between the UI test runner and the host app is to make sure that that you can only interact with elements. You cannot direct the code access. So you just introduce this button, it just taps the button, and then it will go take you to the home screen. In other cases, you will need some cases like where you need to launch the test from the probably the login screen or some other cases. You can have more buttons, or maybe you just reset the app, force restart, we call it. So we just force restart the app. But again, life has its own ways, and we get reality checks always. So we started seeing some tests getting slower eventually. And what we actually deployed this. The first solution we didn't deploy, but the second solution we did deploy in production in the Firebase test lab. And this was happening that some of the tests started taking 1 minute to 3 minutes. And in particular, we found only 2 tests, which were taking a lot of time. So eventually, when we looked into the logs, we found out that UI test runner was saying the UI test runner app is waiting for the host app to be stable, which means that UI host runner app is doing something which is not making it stable, and UI test runner is waiting for that particular action to complete and maybe perform a next iteration of actions. So eventually we had to roll this back, but I think this potential solution, although hacky, has its upside, and if done correctly, this can bring a lot of benefit. And we are actually exploring different ways of how to make it work in our case. Okay, now let's talk about debugging tips. So very few of the things I like about Xcode are these things. Probably I would say Android Studio don't have it, but let's see. So if you see here, as I mentioned earlier, that we run a POC on our different mocking solutions, and we run a lot of tests to make sure that they are stable, because that was the only difference between multiple mock servers, Embassy, Swifter, Hummingbird, and Flying Fox. So if you see, there's this test diamond. If you right click on it, you will get this beautiful menu where you get the options of run test code, in this particular run this test repeatedly. And then you get to this particular screen where you can say run this test this many times, pause on failure, don't pause on failure, run maximum time. So what we would say is that don't pause on failure and run maybe 100, 200 times. And then after that, since we knew that this particular test is not flaky, it's quite stable, the only failure that can happen is from network. So we would make sure that the machine is stable. We run the test for each of the different servers, and then we will gather the result and make our check how stable the servers are. Okay, and this one, debugging logs. This one is also quite beautiful if you want to research on, let's say, what are the fake flaky tests, which part of the test is taking more time. This is quite handy. So when you run the test, you get an XC result report. If you open that test report, you will get such kind of UI. On the left, you have the interactions from the UI test runner app, and on the right, you have, sorry, did I say it on the right? On the left, you have the UI test runner, and on the right, you have the host app. So you can navigate slowly. So if in this particular case, I am tapping on the delivery location delivery text, and it is exactly showing me where the interaction is happening. And it will also show that finding this button, checking existence. So it will also exactly show you this much time is being waited for this UI element to appear. This is very handy if you want to say which part of the test is taking more long, which part of the test is taking shorter. And in the start, you can say skip login and show home. It's taking almost 6 to 7 seconds, as I mentioned earlier. So this is pretty much it for the iOS. Now I will pass the mic to Bashiri for the Android stuff, and QA will happen at the end. Thank you.
Hi. My name is Bashiri. So I am an Android engineer here at Glovo. So here is the agenda that we will tackle during today. So first, we were where we focused, and the second point is from where we started, alternative selection, improvements, and challenges. We have a lot of things in common with EOS, so you will find that we had the same journey. We had different problems, but we have different problems, but we had the same journey. So yeah, where we focused. So in order to have consistent UI testing ecosystem, you need to tackle different aspects. And of course, The first one is infrastructure. Developers only see like the EDO. So they focus more on the writing part. They just write the test and like run it in their EDO. But as a platform engineer, so you are tackling the whole ecosystem. So as I mentioned, the infrastructure, either using Firebase, Google Cloud, Amazon, the solutions that are available in the market, or other solutions, the other solution, whatever you prefer. So, and also there is where to run, either virtual or real device running. So in Android, we have Android unit runner, we have flank, we have fork, we have marathon, and different solutions. And when you run these tests, you need observability. Also, for the UI test, either you will rely on a real network or you mock your network, and for writing. So the standard way is Espresso, but there is other wrappers around the solution, either Appium or Barista or whatever solution each company prefers. So for us, we started by focusing on the highlighted part, infrastructure, observability, where to run, running. We try to make the solution consistent, or the solution that we propose more consistent and more stable, in order to advance to like writing and maybe focus on the network part. So we will focus on the highlighted part first, and then we will discuss the writing part. So yeah, from where we started. So we used to have Amazon Device Farm, and we run it nightly. For each failure, we send a notification in Slack. And we are tagging, you can see Android customer, we're providing the link. So, and we're doing it more or less nightly, or when someone's like rerun the test, the UI test. So we tag, no response, no interaction. We tag, no response, no interaction. We tag, and this is how we come up. We needed to find a solution to make engineers like interact and fix UI test and yeah, and investigate. So okay. So first, we will discuss hardware infrastructure. So mainly, we will be choosing from the standard solutions that are available in the market. So Firebase, Google Cloud, or Amazon. And in order to find the alternative solution, we had a clear idea what we want. So what is a good UI testing infrastructure? Of course, stability, like we need a stable platform, a tooling, we need like an easy to interact a solution. Insights on execution, we don't want a black box, and we want it to give us like insightful idea in order to make actions. Customization, we don't want to not be able to customize the solution that we choose. Of course, the speed, we want like fast like infrastructure, that interaction, and also the integration, everything will be fast. And also the accessibility to the results, either video or like logs or whatever. And for security, we don't want to leak information. And we had other like factors like sharding support, platform support. We want quick access, quick support if we face any issue, and of course some pre-installed apps because we are using heavily Google Maps. We want to customize the device, and we want to some applications to be installed in order to really test some of our functionalities. Yeah. So, and of course, the most important thing is cost. So you write maybe 30 pages of an RFC, and the thing that engineering managers and VPs sees is cost. So this is why we, so cost. So yeah, since we had a clear clear requirements. So we started by eliminating some of the solutions. They are not bad, but they don't suit our needs. So for example, for Appium, it's doesn't support native testing. So as you may know, so it parses the hierarchy and it interacts with the application as a black box. And of course, it doesn't support dependency, not doesn't support, but it doesn't interact well with dependency injection, since we want to customize like some of our objects that we are injecting. The second one is Sauce Lab. So the confidence, the tool looks promising, but like the confidence to compete against like the solutions that we were considering, Amazon Amazon Web Services and Amazon Device Farm and Firebase Test Lab, so is low. And also Browse Stack, so they had, we noticed that it's a little bit complicated to configure for large teams, and also they have the focus like broad. So we want a solution that they have the focus on the mobile testing, not like scattered. Second one is Perfecto, not the second one, the fourth one. So the documentation is outdated, so and we didn't had a clear idea what are the features and how to navigate in the documentation. Of course, it's not like a strong argument, but because like if we struggle to find the documentation, so it shows like how the tool how the tool is. So it will be hard to find how to find documentation for feature and also to navigate the functionalities. For emulators, it. So high pricing, and it was like handled by a single person. So we left with emulators or Amazon Device Farm or Firebase Test Lab. So since like we had the same journey with EOS, so we tried to like see what are the benefits for each solution. For the emulators, it was like it needed dedicated bare metal hardware, and the configuration was hard. The maintenance, it's feasible, but since we had like a tight deadline, and also we want to time box the building of our proof of concept, so we tried to not invest a lot of time, and since like we struggled to make it work, so we said like if at the POC building phase it was like complicated, I think the maintenance also will be complicated. For Amazon Device Farm, the thing that was noticeable is that they don't have the sharding support, and also we noticed that in their in GitHub issues, there were no interaction around like an issue that is to support sharding, and we want to run in parallel multiple UI tests. And also the pricing between Firebase and Amazon Device Farm. Firebase was acceptable comparing to Amazon Device Farm. So what's the best among the solution that we have proposed? Of course, it depends on the team. So the team size, the scalability, and how often do you want to build you change your code base or to run your UI tests. Yeah, it depends. So we went with Firebase Test Lab. It has like stable infrastructure, the speed, because we built a POC, and we had done comparison between the different solutions. It has the sharding support, user management through EIM, and also the platform support, security, and the scalability. We can choose either virtual or real device. And also it doesn't support the test rerun. But it supports it does support the shard rerun, but it doesn't support the test rerun. What I mean by test rerun, so if a test fails in a suite that is run in a shard, we rerun the whole shard, but we don't run a single test. So we will discuss a solution that we propose in order to implement the test rerun. So we went with Firebase Test Lab, and now we are missing the where to run. either real device or emulator. So since Firebase Test Lab offers a variety of devices, around like 90 options, so and also with GitHub Action, we can use the capability that GitHub Action offers us, which is like running in a matrix. So we iterate through all the devices that deemed that can perform well, and we come up with like 3 devices that are winning. So Panther and BlueJay and Oriole. It's a kind of like strange Google. I don't know what they are choosing animals. We are struggling with Android Studio. They started with candies, and then now they are going to animals. I don't know if anyone here is using Firebase Test Lab. Panther or BlueJay or Oriole. Do you know what this stands for? Okay, so Panther is Pixel 7, and Oriole is Pixel 6, and Pixel 6a is BlueJay. So it's weird, but so we compared the device based on time of execution and also the total time of GitHub Action, total step time, and the failures and success and device capacity. Why we choose also to compare based on the GitHub Action total time? Because in some devices, uploading the artifact was not that fast. So this is why we try to compare like the GitHub Action total step time and also the time of execution, because sometimes we notice this difference. And also for the failure and success, some devices like perform weirdly. In some devices, we noticed that we had a lot of failures out of the box because the device was not stable. We didn't investigate a lot, but we tried to choose the best stable devices. And of course, for the device capacity, it's the last one that Google, it's a kind of a way that Google promises us, hey, this device is likely to be provided by us. So also we based our comparison based on this device capacity. So yeah, now we know that we are going to run our UI test. I forgot something. So also we run our UI test on virtual devices, because we have, since we are running in GitHub Action, we have a way how to switch between virtual devices and physical devices. Sometimes when it happens just once, when physical devices were not provided by Google, we quickly switch to virtual devices. So it's a kind of having a quick fallback to a virtual device. So yeah, now we have where to run our UI test. So we went to running. So for the UI test, in order to run UI test, we need to have a runner that like parses annotation, parses rules, parses like set the order and keep track of like the unit UI test. So we have we will discuss like the solutions that are available in the market, mainly like Android unit runner, Flank, Fork, Marathon. We didn't go with a lot of solutions, but we evaluated the ones that I mentioned. So mainly the requirements that we needed were clear. Also, native implementation, like support retries, clearing the state, being able to record the videos and to integrate with Firebase Test Lab, since we adopted this solution, and also to be extensible and customizable. So Marathon. Marathon is a solution that has a lot of like, it provides a lot of functionalities and features, easy data clearance, smart retries, flakiness strategies. They try to combine like all the problems into one solution. So one of the drawbacks that we found is like mainly it's a kind of black box, and it's configurable by a marathon file. And for us, we want extensible solution in order to maintain it and also to own the extensions that we develop. Flank, so as mentioned by EOS, by Sad, so they used Flank in order to solve the problems that they have. But for us, so normally we didn't have the same issues, but for Flank, normally they offer no hassle, easy data clearing, flexible integration, and device variety. So it's a kind of wrapper around Firebase Test Lab, but it's paid. And also we, so Fork, so it has some features, mainly like the same features that the other competitors offers. The disadvantage is the data clearing, and it's not actively maintained. Right after we adopted like our solution, we noticed that the repository was archived. So we had done the right choice. So, and of course, the Android Unit Runner, so the official Google solution, it's supported by Firebase Test Lab and easy integration with CI. It's customizable. The drawback, the flakiness handling, the manual setup, and of course, if we want to clear the state, we need the orchestrator. With which solution we went. So we choose Android Unit Runner with orchestrator. So I will not go through like more detail about the orchestrator, but normally it's the solution that Google proposed in order to clear the state. So in each test, the state is cleared before starting a new test, and this is what the orchestrator is offering. The solution that we opted for, so it offers native implementations and run, and it clears the state using the orchestrator, being able to record a video, and also it's easy to integrate with Firebase Test Lab. It doesn't have a retries, but we will discuss how we implemented the retries in our infrastructure. So yeah, once we have like the infrastructure set and the running and also the once we have the first infrastructure steps set up, so we try to implement it on the courier application, which is our like small application, and that was before. So the whole test suite run in 33 minutes, and after applying the changes and also tweaking the application, because when we implemented the orchestrator, we had some issues that are related to state and the data store. So here is how like it looks. So from 33 minutes to 1 minute, here we have 4 shards, and the 4 shards run in around, the maximum is 1 minute. So yeah, looks nice. So yeah, so now like we have the infrastructure, where to running, and we need observability. So you can't improve what you can't measure. So, and for the observability, we want to have visibility over test suite duration, failure per test and per team, and also the flaky tests. We are running on GitHub Action using Google Cloud command, because we adopted Firebase Test Lab. When we run our UI test suite, so Firebase returned the results from the device to Google Cloud, and we have the results on GitHub Action, and using our custom GitHub Action, we are pushing data to Datadog. So this is how overall like architecture looks like. So GitHub Action is interacting with Google Cloud storage, because on each test, Firebase is creating a folder that has the data, either test results or video or any information that we can extract in order to reuse. For our case, we reused it for the observability. And of course, also, since we have access to our GitHub repo, we have the GitHub ownership, from where we merge all the data and we send it to Datadog in order to have complete observability over the results. So here it is. So the dashboard here, as you can see from left to right, the flaky tests, we have the failed test, test duration, and test ownership. For the flaky test, we can see that here we have the top 15 offenders, and the most important data that we have is the test name and also the owner, so the team that owns the UI test and how many times it's flaky. And also we have the test duration, the top offenders that we can quickly pinpoint in order to let the team know that their UI test is taking too long to run. So yeah, as you can see here, so with the team, we can pinpoint the team and also quickly share the information that there is a lot of flaky tests happening. So yeah, so in general, so the flaky test, just in order to introduce the solution that we proposed, so what is the definition of flaky test? So flaky test is in a test result for a test, we have a failure and we have a success. So if we have in the same file a success and failure, so this test is considered as a flaky test. So for example, this test one is a flaky test. We have the name, class name, and time. So this is how the standard unit output looks like. And in order to implement the test rerun, we need to save first the failed reruns in the device and pull it, and then try to merge all the information into one file. So normally in the diagram, this is the most important thing. So first we run the test, then we rerun the failed test, then we saved the failed test records, and lastly we get the rerun record, which is an XML file that we built in the device, and we merge the files that we get from each device. The device is the shard. So, and with this, we will have the test rerun results and also the shard rerun results in one file. And with this, we can submit it to Datadog or our observability, and we can get the flaky test results. So yeah, and this is how the final file looks like. We have the shard one results, shard two, and it depends on the number of shards. Mainly the test case. This is how it looks like, the name and the class name and the time. So yeah, so we set up the observability, and we found a solution for the flaky test and the test rerun within the test suite. So after setting up the infrastructure and implementing the solution and running the solution on each merge into develop, so we wanted also to improve the state of our UI test, which is focusing on the writing part. Of course, flakiness is a journey, so we try to collect data. Of course, we have the data, and also we had the teams that has the most flaky test. So for example, here we can see that Android has the highest number of flaky tests. We can quickly pinpoint it, share it with them, try to tell them that they need to fix the flaky test. And since we have the list of the flaky tests, so we can just share with them the list and they can tackle it. Taking into consideration the order, we will advise them to tackle the most offenders and the tests that are likely to flake on each run. So, and of course, in order to help developers like quickly pinpoint the issues, we prepared a list. We had a document which is called the standard UI testing that we shared with them. Of course, here the reasons are obvious, but sometimes it's a good practice to share the information with developers. So for example, here we had wrong, outdated JSON, an adapted test, and of course, like network and endpoint modifications, and also like when we changed items into the UI. So we shared with them, and then we tried to involve developers in order to like help them fix the UI tests that are flaky and raise awareness around like flakiness. And of course, so here, since we had a list of the top offenders, as you can see here, so we have, for example, the first test 22 seconds, 16. So we had like a road or path to take, or a clear like issues to tackle. So we started to investigate, and we come up with a bunch of solutions based on the infrastructure that we choose. So first, we built some custom extensions using the view matchers, view actions, and view assertions that Espresso is like offering. And with the help of idling resources, we optimized a bunch of tests. And also, since we had different steps when we run our UI test, so we have the building of our artifacts, and we had intermediate steps, and also at the same time we have running UI test. So we tried also to improve the build time of the artifact. So for example, some of the improvements is we don't build since we have a lot of languages in our application, we try to focus on only English. Maybe in the future we will have some cases that we need to test left to right language, but for now we are building the artifact just with English, which around like it optimized around like 40 seconds if I remember. And since we are using the robot pattern, so we are dividing the what and how. So some changes that we are doing to the core are propagated. So for example, here we had an example. We implemented like a legacy implementation on retrying to click on a button in the dialog fragment, and it was like an issue with Android 10, but it was in the code. After investigating, so we found out that we can like do it just for Android 10 and below. And with this change, so for example, we can see here that the first test, it ran around like 20 seconds. And after applying this improvement, so now it's blocked because like it has some issues, it crashes. And with Espresso, when it crashes, so it takes 5 seconds to recover, which is like a drawback of Espresso. So this is why when we implemented this solution, it's kind of, we prevented Espresso from crashing. So yeah, this is like, it runs in 5 seconds. And as you can see, when we applied the change, it didn't affect only one test, but it affected around like 17 like tests. So with when we divided like the how and what, and also using the robot pattern, so when we do one improvement in one part of the core, so it's getting propagated to the other part of the UI test suite. And yeah, so as you can see, like when we tried to raise awareness, do the optimization, we went from like 3 minutes and 40 seconds to 2 minutes and 30 seconds per test suite. You may say that you may see that in the first screens we had like 22 seconds and it was green, and then in the later like slides we had like 12 seconds and it was red. So when we set the baseline, when we started, we tried to make things stable. We tried to improve on flackiness, and then we tried to improve on the time. And this is why when we had everything, we tried to raise awareness around like the tolerated test time. So we reduced like the threshold to 12.8 seconds in order to raise awareness that we can reach like a lower running time per test. And we had like we shared that we can achieve it by maybe dividing the test or not aggregating many use case and so on. And yes, so for the flaky test, so normally, like since we have the data, we have all the information, we have the team, when there is a flaky test that reaches a threshold, we are sending a message and tagging the team and also providing the run so they can quickly access it and act on it. And they can act on it, and this is a way how to like try to target the team that owns the test and not like propagate the information and try to tag all the team, and that causes them to switch to just like seeing what's happening. So yeah, after we have done the changes, like things now are green, and yeah, and also we see a lot of interactions from developers, and even like we have noticed a weird comment, which is like, Luis. So yeah, thank you very much. And time for questions. Do you have another?
Hi, I'm Daniel. I'm from Travelperk. First of all, thanks for your presentation. It was amazing. My question is for both of you, iOS and Android. How many people was involved in this big development for iOS and Android?
Okay, so for iOS, we started with 2. Actually, David was the one who kicked this off while I was in vacation. But then I think for the majority of the rest of the year, it was 1 developer. But it took at least a little bit of longer time as compared to iOS because we had as compared to Android because we had a lot of extra things to do.
For Android, we were two developers.
Okay, thank you.
Welcome.
Aprovechando. Hola, ¿qué tal? Sorry.
Muy bien.
I don't know. I'm just tired. Again, thank you so much for the presentation. My name is Gabriel, and yeah, also from Travelperk. I want to ask you about the mock. You said that you don't get any response from the real server. You just use mocks, right? Because your face was like no, but okay. If you can go deeper in this sense, and also like how you maintain your mocks updated with the changes of the backend, because
Okay.
that's something that also can
Okay,
usually
I
break
think
the
I can
test?
tackle that. So of course, on both Android and iOS, we use mocks. So one of the reasons I actually skipped to mention, not to make the presentation too long, that since we were running nightly tests, most of the actual failures were happening because they were outdated mocks. So, but when you are merging, when you are merging and there is a check involved, if you are missing something, it would detect it there. So your mocks are always updated because you are running it, you are running it as part of CI checks. So your UI tests should always be updated, or either you're not adding UI tests. If they are there, they should work. Otherwise, you don't get to merge your PR. So that's how your mocks are always updated.
Yes.
Yeah.
And I just want to add, so since like we are doing like small changes in PR, so normally when we change the models or we change like the model of the network, so we need to change also the UI test. So the changes are minimal. So we don't have like now a way how to capture a network and update it and update the mocks automatically, but mainly we are doing it manually. Developers, they take care of updating the mocks and yeah, the models.
Just to add on top of it, the hardest thing for us, I would say, like the hardest thing in terms all of this was to make the test faster so that you can actually run them as PR checks. So because the other problems were actually 70% of the problems get solved by that, but you have to first figure out how to run them fast so that you can bring them in at the PR level, and then of course the reliability and that fact. Thanks.
Also keep in mind that these are not contract testing, right? So the response is not going to be in sync with backend. It's only in sync with the change in the clients. More questions? Yeah, and you know the answer.
So, Sad, you mentioned that on iOS you went from Wiremock to FlyingFox, right? So you brought the web server into the app during testing.
Yes.
Did this have any impact on performance of testing, or did you notice any impacts, on duration and so on?
Okay, so actually, when we started working on this particular sides of the like bringing the mock server into the UI test runner, I was actually concerned about this. But later on, I think my concern was not even valid. It's so amazingly fast for some reason because they are super lightweight servers, all of them. The only difference is stability we got, but they are super fast. When you run the server and you append all of mocks, let's say you are appending 50 large mocks, very large mocks, even those kind of large mocks which you open a JSON file and then you see that some your UI editor tool is having difficulty to, you are actually facing scroll hitches. That kind of particular mocks are even loaded in terms of milliseconds or even microseconds, I would say. So you wouldn't even notice.
Well, you keep thinking about questions. You have here a form to provide feedback to let us know if you like and what we can improve.
Yeah, provide us feedback.